Hi guys, so here we are with our second tutorial, more wave vocabulary. Before we go on to the new stuff, let's just real quick review what came up in the first tutorial. So we talked about crests and troughs. The crest is the top of your wave, the trough is the bottom of your wave. We talked about wavelength, which is the distance either between two troughs, like I have it drawn down there, or the distance between two crests. And finally, we talked about amplitude, which is how high up your wave goes above sort of the midline where your string or whatever started from. So that was what we started with. Let's go on to some other vocabulary. So I'm going to go over four concepts: frequency, damping, velocity, and I'm going to revisit medium, which came up in the first tutorial. I'm going to do this using the PhET simulation because it's much easier to understand these things as you watch an actual wave, and then I'll give you the definitions. It's really important, though, that you listen to the explanation, not just copy down the definitions and try and memorize them. Okay, guys, so here we are in the PhET simulation, and we want to talk about frequency. So you can hear the word frequent in there, so what's happening more or less frequently? Well, if I slide my frequency slider to the right, you're going to notice that what I get more frequently is crests. When the frequency is all the way to the right, I've got about 4 squiggly crests in this space at any one time. So there's lots of crests and troughs. If I slow my frequency down really low, then I get just a few crests in the same amount of space. Looks like I really have just 1 or 2 right now. So frequency is really easy to see visually, right? As I slide the slider over, you're just getting a tighter and a tighter and a tighter wave with more and more crests. How do you actually measure that? Well, you would measure how many crests pass a certain point in a certain amount of time. So it would be like you were standing over there by the picture frame and counting the number of times that a wave crest passed you. That's what frequency is. This is very different from how fast the wave is moving or the velocity of the wave. Let me show you the difference. If I pause this and I turn the amplitude all the way down to 0 and start it back up again, now, because I have no amplitude, there's no height to my wave, so I have no wave. And if I start adding amplitude back, watch and see that it's going to take time for the first little wave that I made to travel to the picture frame. How long that takes is the speed or velocity of your wave. How long that takes to happen does not depend on the frequency. I can have lots of little waves, or I can have hardly any, and the velocity can be exactly the same. And this is actually true of light, which is a wave that has lots of different frequencies, but it all travels at the speed of light. So last but not least, I want to talk about damping. So far we have had zero damping or none when we were using the PhET simulation. So I'm going to go back and give myself a wave to work with. And this is what happens if there's no damping. But if I increase the damping, watch what starts to happen to our wave. You'll notice something is decreasing as we move left to right, and what's decreasing is the amplitude. So what's happening is the material that the wave is moving through, the medium, is actually slowing the wave down because of friction. So damping is when a wave begins to sort of lose its amplitude over a certain distance because of friction, because energy is being dissipated and it's being lost to the surroundings. So the more damping you have, the quicker your wave sort of disappears on you. And that is the additional vocabulary.